Students, today we are going to study transformer. Transformer is a device used for converting low alternating voltage at high current into high voltage at low current and vice versa. Symbol for transformer is, you see, we draw one coil, we draw another coil, and between these two coils we draw two parallel lines. It is symbol of transformer. Now, principle. Transformer works on the principle of mutual induction. That is, if two coils are inductively coupled and when current or magnetic flux is changed through one of the two coils, then induced EMF is produced in the other coil. Construction. It consists of two coils wound over a soft iron core. P stands for primary coil, S stands for secondary coil. Now, to minimize AD current, this soft iron core is laminated. Soft iron core is laminated. Now, students, we know very well there are two types of transformers, step-up transformer and step-down transformer. In step-up transformer, number of turns of secondary coil is more than number of turns in primary coil. Mathematically, we can write Ns more than Np. N for number of turns. Ns more than Np. The primary coil is made of a thick insulated copper wire, while the secondary coil is made of a thin insulated wire. It converts a low voltage at high current into a high voltage at low current. Now come to step down transformer. In case of step down transformer, number of turns in primary coil is more than number of turns in secondary coil. Mathematically, we can write Np more than Ns. The primary coil is made of a thin wire and the secondary coil is made of a thick wire. It converts a high voltage at low current into a low voltage at high current. The AC source or input is supplied across the primary coil and we get transformed signal or output across the secondary coil. Theory. Now, let us consider the situation when there is no load or no load is connected to the secondary coil. Here no load is connected to the secondary coil. Let Np be the number of turns in primary coil and Ns be the number of turns in the secondary coil. Then induced EMF in primary coil, induced EMF, it is E, curly E, P for primary, induced EMF in primary coil will be equal to minus of Np d phi upon dt, and induced EMF in secondary coil E with S is equal to minus of Ns d phi upon dt, d phi upon dt. Now, where phi is magnetic flux. Now, if we divide this EP is equal to minus of NP d phi upon dt by ES is equal to minus of NS d phi dt, we get induced EMF in secondary coil upon induced EMF in primary coil is equal to number of turns in secondary coil upon number of turns in primary coil, and this ratio is called transformation ratio. It is represented by K. K is transformation ratio. If we assume that there is no loss of energy, then output power will be equal to input power. From last relation, we have seen this transformation ratio. We have got this transformation ratio. Okay, and from this relation, output power is equal to input power. Since we are having power, we can write induced EMF for secondary coil into current through secondary coil is equal to induced EMF in primary coil into current in primary coil. From this relation, we can get one more relation. Now, from previous relation and this relation, we can write induced EMF in secondary coil upon induced EMF in primary is equal to NS upon NP is equal to IP upon IS. Now, our basic relation for transformer. Madam. Since in a step-up transformer, it follows IS less than IP. Thus, in accordance with the law of conservation of energy, a step-up transformer increases the voltage by decreasing the current. Similarly, a step-down transformer decreases the voltage by increasing the current. So, a transformer neither creates nor destroys the electric energy. In other words, we can say it obeys law of conservation of energy. The efficiency of a transformer is defined as efficiency represented by eta is equal to power output upon power input into 100%. The efficiency of real transformer is fairly high. It may be 90 to 99%, though not 100%. The main causes of energy loss in transformer are copper loss, eddy current, hysteresis loss, flux leakage, huming loss. They are main causes of energy loss in transformer. Come to copper loss. Some electrical energy is lost due to heating effect of primary and secondary coil. So, this can be minimized by using thick copper wire of low resistance. Eddy current, again some heating effect we get. It can be minimized by using laminated iron core. Third cause is hysteresis loss. It can be minimized by using core material having narrow hysteresis loop. That's why we consider soft iron core. Now, flux leakage. It can be minimized by winding the primary and secondary coils over one another. Last cause is humming loss. Means some humming sound we get due to vibrations of transformer. And it is this sound, this loss of electrical energy, it is due to magnetostrictions. Students, see, transformer is an AC device, alternating current device. It will not work on DC, direct current, and frequency of DC will not affect on the transformer. Some important applications of transformers are, for number one, small transformers are used in radio receivers, telephones, loudspeakers, etc. Second, the voltage regulators for TV, television, refrigerators, air conditioners, computers, etc. Third, step-down transformers are used in induction furnaces for melting metals, also used for obtaining large current for electric welding. Number 4, a step-up transformer is used for production of X-rays. Fifth one, it is very important, in the transmission of electric energy from the generating stations to the consumers.